So part of understanding kinetics is studying reaction mechanisms. Mechanisms are the steps of reaction that produce a product. And the steps are actually the collisions between the different components and the rearranging of those electrons, which are in the bonds, to then rearrange the atoms themselves. Sometimes reactions happen in a single step. That's great. Those are elementary steps. Sometimes a reaction will actually occur in multiple elementary steps, where you have a sequence of collisions that must happen to go from your reactant all the way to your product. And in between those different reactions, you're forming what's called intermediates. If you measure the rate of that process, you're not able to measure the individual rates of each step. You're seeing a reactant depleting and you're seeing a product growing. And the intermediates themselves are produced and consumed. And sometimes that can happen so quickly, they're awfully hard to catch. So how do you figure out the steps of the reaction? Well, this can be complicated even further by the idea that not all the steps happen at the same rate. Very rarely does that occur. Instead, quite often you have one step that is very slow compared to the others. This is called your rate-determining step. And that means when you measure the rate of your reaction, that elementary step will be the rate you measure. So that dictates the rate of the entire process, even if there are faster steps before and after that rate. Why is it slower? It's typically due to activation energy. It's just harder to get that reaction to go. It can also be due to sterics, meaning your molecule is really big and it's hard for it to collide in the right way. So think back to collision theory. So let me show you kind of an example to help you understand this idea of rate-determining step. So I have a setup where I'm going to use water, and I have water in a beaker. This is my reactants. So they're just waiting for my reaction to start. When I pour the reactants into this funnel, that's the first step of my reaction. And the rate at which that water gets transferred to the funnel is the first rate of the first step. But then the water will flow through the funnel. That would be the second elementary step of my process. And the rate at which the water flows through is dictated by how fat that funnel is. So if I pour the water in faster than the funnel size allows it to flow out, then the rate-determining step is going to be the second step, or the flow out of my funnel. And it doesn't matter how fast I pour the water in. All that matters is that it's faster than this rate-determining step. And if I measure the production of products, I won't be able to see the rate at which I pour the liquid into the funnel. If I'm measuring how quickly products form, I'm only seeing how quickly that flows from the funnel. So let me show you how this works. So here are my reactants, and now they're going to form an intermediate. I'm flowing into this funnel. And as I form this intermediate, it is consumed, and it will flow into the second beaker, which means it's turning into products. Now, all of my reactants are gone, but not all of my products are formed yet. The rate for product formation is dependent on the slow step, which is that funnel. What happens if I add another step? We'll make our reaction very complicated. I'm going to add another funnel, and this funnel is even bigger than the other funnel. So what that means is now I have the rate of my reactants turning into intermediate 1, the rate of intermediate 1 turning into intermediate 2, and then the rate that intermediate 2 turns into products. Whichever one is the slowest will dictate how quickly I see my products form. So here I'm flowing very fast, and you can see the rate that my intermediate 1 goes away is as fast as I can pour in. I have no reactants. I've consumed everything from the first step of my reaction. And then the second step is still reacting and my products are still forming. So the rate-determining step dictates the formation of the products, despite there being faster steps before it. So that's how rate-determining steps help us understand kinetics and help us understand the process, and how they link to mechanism. Learn more about this and other chemical reactions by liking and subscribing to Office Hours.